Hello, good people of pre-calculus. We are talking about inverse trigonometry today. Let's go. First thing I want to remind you of is what trigonometry does. In trigonometry, you get a triangle, right? And there's an angle in that triangle. And trigonometry takes that angle and it turns it into a ratio. So for instance, if we were asking about the sine of an angle, that would take this angle and it would turn it into the ratio of the opposite to the hypotenuse. And that's actually what you're doing when you answer a problem like this one right here. See how it says the sine of pi over 4. Pi over 4 is our angle. I know it doesn't look nice like, I don't know, 45 degrees would, but this is an angle. So this is asking you, what is the sine ratio when we have an angle of pi over 4? And of course, you could grab the unit circle, which I've got one right here. And at pi over 4, the y value is roots of 2 over 2. So we know that this is roots of 2 over 2. Now, one of the funny things about angles is that lots of angles can have the same ratio. So for instance, the sine of 3 pi over 4 is also roots of 2 over 2. And the sine of 9 pi over 4 is roots of 2 over 2. And the sine of 11 pi over 4 is roots of 2 over 2. And here's why it's important that these 1, 2, 3, 4 angles can all give us the same ratio. Today we're talking about inverse trigonometry. And inverse trigonometry works in the opposite direction. Inverse trigonometry says if we start here, if we start with the ratio, and keep in mind that these are our ratios. If we start with the ratio, inverse trigonometry, with the little -1 there, takes that ratio and turns it into an angle. So the question becomes, if we start with this ratio right here of roots of 2 over 2, what angle is going to pop out? Is it going to be pi over 4? Is it going to be 3 pi over 4? Is it going to be 9 pi over 4? Or is it going to be 11 pi over 4? Which one of them is going to be the big winner? Because listen, it can't be all of them, because this right here is a function. And when you have a function, that means that over here you can only have one output for one input. So we have to choose which one of these 4 angles we are going to select. Let me talk about that a little bit down here. I'm going to come down to the graph. Roots of 2 over 2 is our ratio. Roots of 2 over 2 would be somewhere around here. It's a little bit smaller than 1. It's like 0.7 or so. So I'm going to draw a line right here at y is equal to roots of 2 over 2. See how it's hitting the function at multiple points? That means that it fails the horizontal line test, which is something we talked about back in the fall when we were first studying inverses. And we have to find a way to make it pass the horizontal line test. And what I'm about to say is totally arbitrary, but it's what the math gods have decided. What they decided is that if you start right here at negative roots of 2 over 2, and you stop right here at roots of 2 over 2, and you pretend that the rest of the graph, all of this and all of this, doesn't exist. If you just look at that little rectangle right there, see how that will pass the horizontal line test. So the answer to our question, which one of these angles is going to be the one, is which one of these angles is between negative pi over 2 and pi over 2. And the answer to that is my buddy, pi over 4. So pi over 4 is the answer. All right. So now that we've got that introduction out of the way, let me show you how we're actually going to do this. Pi over 2 is right here on the unit circle. Negative pi over 2 is right here. So anytime you are doing an inverse sine problem, your angle is going to be somewhere on this side, which means your output, your answer, is going to be somewhere between negative pi over 2 and pi over 2. Okay, the input, the thing that you enter in, has to be one of these ratios right here. And the biggest the sine ratio ever gets is 1, and the smallest it ever gets is -1. So the thing that you input has to be between this number and this number. Okay. So there's sine. For cosine, we have to pick a different interval. Here's the cosine graph. See how if I picked from negative pi over 2 to pi over 2, look at that region between my fingers there. See how that would fail the horizontal line test. So we have to pick a different region. The region we're going to pick is right here. Okay. So pretend that none of this exists and none of this exists. When you're doing an inverse cosine problem, your answer will always be between 0 and pi. Now on the unit circle, 0 is right here, and pi is right here. So we are looking at the top half of the graph. Okay. So your output will be between 0 and pi. Your input, the biggest the cosine ever gets is right here, it's 1. The smallest the cosine ever gets is right here, it's -1. Last one, tangent. For the tangent graph, we say that there's one complete cycle between this asymptote and this asymptote. This asymptote is at negative pi over 2. This asymptote is at pi over 2. Those are not on the graph, so I'm going to write them in. So your answers will be in this range. Now, I want you to note that because there's an asymptote here and an asymptote here, we're undefined at pi over 2, and we're also undefined right here at negative pi over 2. So for your output, I'm going to put soft parentheses on this. Okay, because you can't actually hit the two endpoints. The inverse tangent is undefined there. For the input, see how this right here runs from negative infinity to infinity? So that means you can input anything you want into a tangent function. All right, so here's the biggest thing that you need to take away from what we just did. Inverse sine is the right side. Inverse cosine is the top. Inverse tangent is the right side. Right side, top, right side. Right side, top, right side. Remember those. Okay, now here's what your problems are going to look like. First one, it asks us for the inverse sine of negative roots of 2 over 2. This is the ratio. Your answer is going to be an angle. The way that I want you to solve these is I want you to draw a coordinate plane, and then the first thing you're going to say is inverse sine. Is that the one that's on the right or on the top? If you're not sure, you can just flip back to the last page. Inverse sine, right side. Cross off, cross off. Next thing you're going to say, we're down to quadrants 1 and 4. Of those two quadrants, which one has a negative sine ratio? Well, sine is the y value, so it would be negative down here. So we're going to cross off quadrant 1. Next step, draw a triangle in the fourth quadrant. And let's label the y value as negative roots of 2 over 2. The problem is asking you what this angle is right here. Now, one of the things I want to remind you is that if it's inverse sine, then your answers have to be between negative pi over 2 and pi over 2. So we're looking for an angle that has a sine ratio of negative roots of 2 over 2 and falls between those two. And the answer is going to be that since 45 degrees goes with pi over 4, and this is in the negative direction, this is negative pi divided by 4. All right, let's keep rocking and rolling. B. Inverse cosine. Recall that inverse cosine has to be between 0 and pi. So that's the top. So I'm going to cross off the quadrant on the bottom. Step 2. Look at the sign on the ratio. The sign is negative. So in which of these two quadrants is the cosine negative? Answer. Cosine is the x value, and x is negative over here. Step 3. Draw a triangle in the second quadrant. The x value is going to be negative roots of 3 over 2, which means this has to be 1/2, which means that this reference angle right here has to be 30 degrees. Okay? Now, quick reminder, since it's been a minute, don't forget that pi over 6 goes with 30 degrees, pi over 4 goes with 45 degrees, and pi over 3 goes with 60 degrees. Those are our buddies. So the angle we want is this one right here. We know that 30 degrees is a pi over 6, so this must be 5 pi over 6. 6 pi over 6, take away 1. Okay, let's keep going. Take a look at C. Arctan. Now, I should mention that when you see arctan, that means the exact same thing as inverse tan. So we have two names that mean the exact same thing. Arctan, inverse tan. So you want to think to yourself, inverse tangent, is that the right side or is that the top? Reminder that inverse tangent is from negative pi over 2 to pi over 2. So that's the right side that you're working with. Boom, 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 boom. Cross off, cross off. The negative tells us that since tangent is y over x, we must be in the fourth quadrant because y over x would be negative right there. Okay. So we're looking for an angle right here so that y over x would be equal to negative roots of 3 over 1. So I like to tell myself that this right here is telling us that y is bigger than x is. So that means that the y must be the roots of 3 over 2, and the x must be 1/2. You can check. If you calculate y over x, I'm going to kind of scoot into this space over here. Y over x is equal to negative roots of 3 over 2 divided by 1/2. You'll get that that is equal to negative roots of 3. So we're good. All right, now that we know this is negative roots of 3 over 2, we know that this must be a reference angle of 60 degrees. Therefore, your answer is going to be negative because we're moving in the negative direction. And since it's a 60-degree angle, that'll be pi over 3. Continuing on to D. You're going to see problems like this where it is an inverse trig function that we don't like secant. What I'm going to suggest to you is this. We know that secant and cosine have reciprocal ratios. For instance, the cosine of an angle is equal to the adjacent over the hypotenuse, and the secant of an angle is equal to the hypotenuse over the adjacent. And we also know that this right here is the ratio. So what you want to do is you want to take that ratio and flip it over. Saying that the inverse secant is roots of 2 is the same as saying the inverse cosine is 1 over roots of 2. So I took that ratio and I did a little flip, or I took the reciprocal. Why? Because we know that cosine and secant have ratios that are flipped over. So flip over here means flip over here. The next thing I'm going to say is that 1 over roots of 2 is the same as roots of 2 over 2. At this point, you're going to make your coordinate plane. You're going to say cosine is on the top. Cosine is positive, means we're in quadrant 1. We want the x value to be roots of 2 over 2, which tells us that this is a 45-degree angle. Therefore, our answer is going to be pi over 4. Okay, next one. This one's a two-parter. You would think that the inverse sine and the sine would cancel each other out, but they're actually not going to, and I'll explain why in a second. This one, we start here. Now, this is like a classic Unit 6 kind of inverse trig problem. On this one, you're going to start by saying, I know that 2 pi over 3 is right here. There's the angle 2 pi over 3, such that this is a 60-degree angle. And if we completed our triangle, we would get roots of 3 over 2 on this side and negative 1/2 right here and a 1 in that position. So the sine of 2 pi over 3 is equal to the opposite over the hypotenuse. So I have not done the inverse sine yet. I'm going to leave that here. But I've evaluated that the inside operation is equivalent to the square root of 3 over 2, because I got that from looking at this triangle. Now, second coordinate plane. Sine is always on the right side. Sine has a positive ratio, which means we're in the first quadrant, which means that we want this triangle right here. So this is, once again, a 60-degree angle, but now that amount of turn is just pi over 3. Weird. Last one, every so often this happens. You get one like arc cosine of 1. And the arc cosine of 1 means, well, first we're in the top half. Where is the cosine equal to 1? Oh, well, this one's actually not going to be in quadrant 1 or quadrant 2. It's going to be on one of the quadrantals. Arc cosine of 1 means where is the x value equal to 1? That would happen right here. Now, at that point, we haven't done any turning at all. So our answer is going to be that the arc cosine of 1 is equal to an angle of 0. All right. With that in mind, I did the left side. I would like you to pause the video right now. So hit pause. And then I want you to attempt the right side and then come back and check your work. Okay, and I'm going to assume that you have now attempted those problems and are ready to check. So here are your answers. You should have pi over 4, negative pi over 4, negative pi over 6, pi over 6, 1/2, and I should explain this one a little bit. This says inverse sine of 2. Recall that the input has to be between negative 1 and 1. So it's actually impossible to get a ratio of 2. If that's hard for you to see, just think about the sine graph for a second. Sine, the maximum right here is at 1. So 2 would be up here. Since there is no angle that would give you a ratio of 2, that means that this is going to be impossible. Okay. And that is our lesson. Nice job.